Hi everyone, I'm Lucas. I'm a developer advocate at StarkWare, and today I'm going to speak about Cairo 1.0, the next evolution of Cairo. So, a small overview of Cairo today. It has been in production for 2 years. It started in 2020 with StarkX and in 2021 with Starknet. It has processed over 200 million transactions and more than $600 billion of cumulative trading. There are over 15,000 Cairo files on GitHub, and trust me, it's a lot easier to write than polynomials. This is a snippet of Cairo 001, the first version of Cairo that was used in StarkX, if I'm not mistaken. And as you can see, it's way harder to read. There is less abstraction. This is the old syntax. The new one is this one, which is more readable. It looks like Rust or Solidity, which are well-known languages. So it makes it easier to write and read Cairo. So Cairo is an assembly language efficient to generate Starks. For the record, Cairo has been created by StarkWare because employees had to write the polynomials manually for StarkX, and it was really cumbersome. And if they wanted to change anything, it would be really hard, and it will also be really hard to audit the polynomials. So they wanted a convenient way to generate Starks that would be easy to audit and that would be secure. So they came up with Cairo, and as it was not meant for public use, they just designed an assembly language and they went with a code base that was not extensible um, because it was just for them. So it didn't matter if we couldn't make it more abstract or easy to write or having more tools. So now we can see that because there are lots of tools that are missing. For example, a package manager. We don't have one specifically for Cairo. We have pip, which is not great. I don't think that a lot of people use it. We have some community members that create libraries, and thank you because you made life of people easier. But we don't have a rich standard library, which is a problem because we have to rely on external people to write the libraries, which is not a great thing. We have the uint library, but as you know, it's not really efficient. It's hard to use. It's not really clean. So we want to fix that. We also don't have loops. We have recursion. You probably don't like it. I personally don't, and I'll be glad when it will be replaced by real loops. And we don't have also any way to handle errors. Basically, you just assert stuff. If the assert fails, then your whole transaction fails, which is annoying. Yeah, the meme speaks for himself. Cairo is hell, but I'm really sure that it won't stay that way and that you guys will be able to do other memes that will be even better, and Cairo will be a wonderful programming language. So the next evolution, what's the plan? Basically, the plan is that Cairo 1 will be the first major release of Cairo. For now, as you can see, it's 0.10.0. It's minor releases. We want to do a major release because there will be like a major change. We want the developers to be happy. So you want you to be happy by having a language that is easy to use, easy to write, easy to learn, that have a great tooling, that has native functionalities that you guys want. So we're rewriting the whole compiler in Rust to have a cleaner infrastructure. So as I said, it was designed to be an internal language. So we didn't really take the time to do a clean infrastructure. And it's really hard to build on top of it. We're kind of stuck. So the compiler is now rewritten in Rust. And one important point of Cairo 1 is that all the code that you write now will be easily portable to Cairo 1. So except if you write assembly stuff, basically your code should be easily portable to Cairo 1, should be easily compiled by the compiler. What are the goals of Cairo 1? So Cairo 1 basically, as I said, is to make you happy. And what could make you more happy than not having to deal with revoked references? I don't know. Basically, what will happen is that the compiler will take care of what type of the variable you want to create. Um, for example, now when you want to create a variable, you have to specify either if it's a let, a temp_var, or a local. Now the compiler will handle everything and will try to mitigate as much as it can the revoked references. So you won't have to debug your code blindly with weird temp_vars everywhere. We'll also have loops. So bye-bye recursion, except for the one that love it, but I don't know if there are many people that love it. We'll also have Boolean expressions, complex Boolean expressions. For example, you'll be able to do if X and Y or Z, then do something else, do something else. We'll also have native integers type. So right now, the native type of Cairo is felt. So as you may know, the division is weird with felt, as it's in a finite field, everything is modulo big prime. So divisions act weird. If you want to divide 9 by 3, you won't have 3. You'll have a weird number. So now you'll be able to type your variable to int, and you'll have 3 when you want to divide 9 by 3. So that's super cool. You will, like, math will be really easier with this type. We'll also add error handling. So basically, what will happen is that, like in Rust, your functions will return the value you want plus an error. And then you can check if the error is null or if the error is something. If it's something, then you can choose to propagate the error in your transaction, which will revert it, or to do something else. So you'll have a sort of try-catch, which is also a really cool feature that was needed. We'll also enable easier manipulation for arrays, for dictionaries, and probably other stuff. We'll have also safety for division, overflows, and a lot of mathematical stuff. So the compiler is rewritten, so we'll have a better infrastructure, which will enable to ship features really faster. Right now, we have to work on top of something that was not designed to scale, so it's hard. After having rewritten it, it will be easier. We'll also have the possibility to add more features than now, and it will be performant. As it's in Rust, it will be way faster than Python. So now when you want to compile a big file, you don't have to wait 10 minutes. You can compile it really fast. We'll also have more tooling. So package manager. Question is, do we want to use the Rust package manager, or do we want to create our own? We don't know yet. We'll see later what we do. We also have language server. This is already available. I will show you at the end how it works, but it's really cool. We also want to facilitate the contribution of the community. So you will be able to contribute to the compiler because the repo will be public and because the infrastructure is really clearer. With Cairo 1, we'll also introduce Sierra, which will solve some Starknet problems that we have now. So the problem is we don't sandbox anything to execute a transaction. The transactions are executed in native Cairo. It's kind of safe because of Cairo's memory model. Memory is immutable, so you can't modify anything. But we can't prove failing transactions, which is a big problem because if a transaction is not proven, then it's not included in a block, then we can't collect fees. So if you want to DOS Starknet, you just spam with failing transactions. We tried to mitigate this with the validate entry point that was introduced in 010. Basically, now there is a transaction verification that has a step limit and that will allow us to take fees, but it's not perfect. So we want something that will solve this. We want something that is always provable, even when the transaction is supposed to fail. For example, you're a dApp, you want to check that someone has, I don't know, exactly one token. You do it with asserting that he has only one token, but if the assert fails, the transaction fails, then we can't take any fee. So he can just spam everything, which is not what we want. So now it will be changed to an if. So if x different than 1, return an error, and then you'll be able to deal with the error as you want. You can revert the transaction, you can keep the transaction and do something else. It's your choice. And we'll also be able to count the gas of what's happening in there. So it will be easier to optimize your contract. This solution is called Sierra, so Safe Intermediate Representation, and it's always provable by construction. So the flow now will be that you'll have your high-level Cairo, you'll compile it to Sierra, and then to Chasm, which is Cairo assembly. It's the really low-level Cairo that you probably have seen somewhere in the docs. And then to Cairo bytecode. Sierra is not failing, never failing. It counts gas natively, and it compiles to Cairo bytecode with almost zero overhead. So basically, we solved our problem of fees and thus vector with something that enables you to deal with errors and that doesn't add a lot of overhead. So we solved a problem with like a solution that's almost perfect. About the development process of Cairo 1.0, we have started. We have a POC that works for some snippets. I will show you right after what it can compile. And the expected release is in 3 months, and it will be the repo of Cairo 1 will be turned public soon, I guess. So you'll be able to track everything that's happening in there. You'll be able to try the compiler before it's released. You'll be able to contribute to do feedbacks. I don't know, whatever you can imagine with a public repo, you'll be able to do it. So now I'm going to show you what's the state of Cairo 1. Here is a Cairo 1 snippet. It's a function that computes the Fibonacci sequence. So basically, it takes as an argument the first 2 elements of the sequence and the number you're trying to compute. Then what it does, it matches on n. So what is match? It's pattern matching. It's like in Rust. Basically, what it does is that it checks if n is 0. If it's 0, then it returns A. If it's not, it returns this, which is the next value of the Fibonacci sequence until it reaches 0 and it returns A. Um, this function is recursive, so this is a choice. This is not because there are no loops. It's really a choice. And what pattern matching will allow is amazing. So you've dreamt of error handling, you have it. If your function returns an error, well, yeah, you can match on the error. You check if the error is 0. If it's 0, then great, everything went smoothly. If it's not, you might have a problem. But you can deal with the problem. If you want, you can propagate the error and revert the whole transaction. So this would work like a fail. If you want, you can also just do something else. If the error is not done, I don't know, you can do something else. The which would be the equivalent of a try catch. You guys have waited a long time for try catch. You'll have it with Cairo 1, and you see that it's already implemented. So now on to the compilation. Oh, let's run the test. So here is the Sierra representation. You don't have to understand what happens here. It's a bit verbose. All you have to know is that that compiles to that, which is CASM, Cairo assembly, which is the lowest level Cairo. And then we can compile this to bytecode. We can already compile this to bytecode. So this is for the compiler. Now for language server. As I said earlier, we already have it. It's a VS Code extension that can probably work with Vim. I'm not really familiar with Vim, but basically it tells you what's wrong in your code when you write it. So here, I write F, what it says. Okay, doesn't understand what I'm trying to do. Here, it's missing an identifier, parentheses, and curly braces. All right, so let's give an identifier. So let's call it main. Then it misses parentheses, all right, and then curly braces. All right, let's give it everything. Boom, no error, plus the auto format. Okay, now I want to call fib from this. So let's do it. All right, let's call it fib variable. It's not a variable, so it doesn't know what it is. Here, he understands that it's a function that expects 3 arguments. So let's give him 1, 2, 3. All right, error disappeared. Boom. We have our function, and we knew all along what was the problem. So that's what we have for now. We can try to compile this actually. I guess it won't work, but it's a good test. Yeah, no, it didn't work. But we already have pattern matching, and this is huge. I hope that you'll also really like the int native type. I know that some people have been waiting for this. You won't have to use libraries. Everything, not everything, but a lot of things will be with the standard library, and this will be awesome. All right, I hope that you will like Cairo 1 as I do. I'm super excited to see it released. I'm super excited also to know all the improvements that are coming to StarkNet. We will love to have your feedback on the compiler when the repo is public. If you have any, please do reach to us and tell us, open issues, or submit PRs, help us improve StarkNet. Yeah. Thanks for joining and have a good day.